Okay. So last time, let's kind of go back and review, because everything's interconnected. We talked about the definition of statistics, right? And we said statistics was the science or methodology, if you wish, that does three things. It collects, it organizes, and it analyzes data. Notice data is capitalized. This is the key part of this definition in a sense. Without data, there's no statistics. All these things are being done on data, right? So this is something you notice in red. This will definitely be on a quiz. It'll definitely be on an exam. It's very important to understand this. We're doing three things, okay? Most people are just used to computing means and standard deviations. Statistics is much broader than that. Okay, so we looked at data, and we said, okay, what is it? We just said it's a collection of recorded observations that have context. Okay, so this part is not a big surprise. This is not new to anybody, right? But the context is. So we said, okay, there are two key properties of data. The first thing we have to know is we have to know what type of data we're talking about. Are we talking about categorical, or are we talking about quantitative? And on a quiz or on an exam, I'll just simply want you to identify the type and tell me why. Since you can guess 50-50, right? I want you to explain to me why, all right? And we said, okay, categorical, if it's a word, it's automatically categorical. If the response from the raw data is a word, it's automatically. So we said these are labels or categories, hence the name. They can be identifiers. So here we can't have numbers that are categorical, like your social security number, your student ID number, your zip code, your area code. These are all identifiers. They tell you someone information about who you are, right? And rankings. Okay. And then we say, okay, quantitative, that's easy. It always has to be numerical. And it can either be physical measurements, so anything that has a unit, automatically quantitative for our purposes. And count data. Anytime I'm counting something, number of students in a room, number of points on your exam, okay, this is all considered quantitative. All right? So we went through a lot of examples. We had a lot of homework problems on that. And the last thing we talked about was context. And so this starts to get into the part of statistics that is not formulaic. We said context is kind of like the background information. And we need that to make sure that what we think we're seeing is what we're actually seeing. If I give you a salary, like the example of the baseball player, it's only $15,000, you might say that's really low. But if I didn't tell you where, like it's in the Honduras, or I didn't tell you when, like 1957, you come to the wrong conclusion, okay? So context is actually very, very important. All right, so what does this have to do with today's lecture? Well, it turns out that this is important because the type of data we have depends on or determines how we're going to organize it. So that's kind of the key point to today's lecture, okay? We're going to look into the details of that. But I can't do the same thing with categorical data that I can do with quantitative data, okay? Does that come as a surprise? Not really. If you think about it for a second, you can take averages of weights, right? I can take averages of quantitative data. Remember, that was one of the rules we gave for how we know it's quantitative. We can do meaningful mathematics with the numbers. But if I have a household with a male and a female, can I take the average of that? It doesn't make any sense, right? So I can clearly do things with quantitative I can't do with categorical. And we're going to see this is very easy, and this gets a lot more complicated. Okay? So that's the idea. That's where we're starting today. Okay, so I want to start off kind of with a really cool example, the Titanic, okay? Everyone knows about the Titanic, right? Okay, yeah. And, you know, what some people don't really understand sometimes or realize is that the Titanic was probably the most luxurious ship ever built in all of history. It was like the lifestyles of the rich and famous sort of ship. It was just tremendously elaborate and ornate, okay? This is the sort of stuff you see a couple times in a lifetime, right? Incredible. And so we know some facts about the Titanic, right? You know, it sank back in 1912, going from UK to US, and a whole lot of people died. There were over 2,000 people on the boat, over 1,500 died. And those numbers are not exact. It kind of varies, plus or minus 10, depending on the source, okay? But they're all in that ballpark. Now, there are a lot of other statistics, a lot of other facts about the Titanic, okay, that we can look at. So we can actually, if you go back, this is the actual manifest for the Titanic. Okay. All that information, everyone's name, okay, most of the people's names, where they're from, male or female, their age, how many siblings they had, and I don't even know what these things are, okay? But this is the important thing. Whether or not they survived or died, okay? So 1 means they survived, 1 means they survived, 0 means they didn't, okay? And their passenger class, first, second, third, and crew, okay? So we know the passenger class, we know whether or not they survived, we know their gender and their age, okay? And so you notice the first thing about this data set is that it's huge, okay? I mean, this is just the beginning. I'm scrolling, okay? So nobody, unless you're some sort of unusual savant, can look at all those 2,000 pieces of information at one time and get information out of it. Make sense of it, right? So we have to do something with that data. Okay. So we have to organize it. Okay. We have to somehow boil down that data into a form that we can understand just by looking at it visually. Okay? That's the idea. That's what we want to do. We're trying to reduce down all that information to really the important features and have it so that you can look at it immediately and understand what's going on. Okay? And it turns out that there are 3 different ways we do this. We do all of them, okay? The first thing we usually do is we make a table or a chart. Okay? I'm going to take all that 2,000 pieces of information and make a real nice simple table out of that. And so the next thing we're going to do is we're going to plot it. Okay? You know, you've heard the old saying, a picture is worth 1,000 words. This is literally true. Okay? A picture literally contains over 2,000 pieces of information. So this statement is 100% accurate. Okay? And the last thing we're going to do, because a lot of times you want to describe something, but if you're trying to describe a plot, it's very hard to describe something like that, right? I mean, visually, it's really kind of hard to explain what the plot's like. So what we do is we compute these things called descriptive statistics. Sometimes people call them summary statistics, because it summarizes that picture in a few real easy to understand numbers. Okay. And if this doesn't all make sense right now, that's fine. We're going to get into the details. But this is the idea. We're going to reduce it down to a table, plot it, and then we're going to describe that plot in a few simple numbers. Okay? So that's where we're going. And the key concept, again, is the way we're going to do these 3 steps totally depends upon the type of data. What we do with categorical, we cannot do with quantitative, and vice versa. Okay? All right. So let's look at categorical first, okay? And by far, this is the easiest. But we're going to look at 3 different ways of organizing the data. So you think about it. What can you do with categorical data? There's only one thing you can do. You can count the number of people that are in each category. And that's it, right? So it makes categorical data very, very easy. So what we're going to do is we're just going to go through that list. I have Excel do it because it's too hard for a person to do it. But I'm going to go through and I'm going to count the number of females, count the number of males, count the number of people survived. And that's it. Okay? So this is, for example, the data from the Titanic data set. Okay, these are the counts. 325 people in first class, 285 in second, 706 in third, and the crew is 885. A lot of crew. Okay, that's kind of interesting. And you can see that the numbers don't add up to 2,224. Like I said, a little bit of a difference. Okay. Frequency is synonymous with the word counts. It just means the number of. Okay. I'm going to use those terms interchangeably. I'll try to use number of, but just force of habit, I'll use frequency, and that's what the book uses too. So it's a good term to learn. Okay, and so what am I going to do with that? Well, I can go ahead and plot that. Okay, it's hard, even with those few numbers, to kind of make sense of what's really going on. A plot's always easier to look at, right? So all I'm going to do is just put each category down here, okay, on the x-axis. So this is the class of the passenger ticket. And here, I'm going to put how many were in each class, the frequency. And notice this is actually a lot easier to understand. I can look at this. This is a little easier to make sense of rather than look at numbers, right? Okay. So this is one thing that I'll expect you to be able to do. I won't give you a data set as large as the Titanic, but if I give you between 20 and 30 data values, you should be able to count the number in each class and plot it, okay? And do something like this. All right? And we call this, by the way, a bar chart. People call it a bar plot, a bar chart. What are we doing? We're basically taking this table or this chart and just making a graph of it, where the bars are the length of this is how many are in that category, right? All right? Okay, so let's go ahead and do that with our data. Okay, so this is the data set from our class. Okay, so we took a poll and asked what sort of genres of movies do you like, and this is what everyone said. And let's just make a really quick bar chart. Okay. So this would be pretty easy, right? On the x-axis, I'm just going to have each of my categories. So I'm going to have movie genre down here. Okay. And I just put, action, comedy, drama. And I'm just slanting it so I have room on the board for romance and finally other. Notice the spacings don't really matter. We're not plotting numbers, but usually, we like things to be kind of uniform. Okay, it's easier on the eye, right? And so on this axis, what am I going to plot? Just the number of, right? I notice that it goes from 0 to 14, so I'm going to have to leave some space here, right? And you don't have to do this perfectly. I'm a terrible drawer. Okay, just so that it's kind of in the ballpark, okay? So for action, I have, 4 people here? Okay. Comedy, I have 14. A lot of people like comedy. For drama, we have 4. So it'll be the same height as this. And you just try to get it close, okay? Horror, there's 3. A little bit less. Romance, there's 5. And finally, other, we have 1. Okay. So that's a kind of decent sketch. Okay. And so notice how nice this is, though. I can look at this plot, and now I kind of know what people like. I know people pretty much like all these other films the same, except comedy. There's a whole lot of people that like comedy, okay? So again, I think plots are always so much nicer. All right? Okay, so what else can we do? Well, you notice something with the Titanic. Think about what your eye is doing for a minute. Your eye is not really focusing on the actual numbers, right? You're focusing on the relative heights of those things, right? Like this group has a whole lot of people. This group comparatively has a little bit. So what we're actually looking at is, in our eye, we're looking at the percentage in each group. And that's a lot of times much more interesting. And so we went ahead. We already did that part. So the second way we're going to organize the data is, now we're going to make a table of the percentages from each group, not the frequencies. Okay? And so for the Titanic, that's kind of something we're more interested in than actual frequencies. Okay? So how do we get the percentage? It's just going to be the ratio, right? So how did I get the 15%? I put the 285, so for the Titanic, I put the 285 over 2,201. That's the fraction of people that were in the Titanic, right? And I'm going to go ahead and compute that and then multiply that by 100%. So this is how I got 15% for the first class. All right. Now, one thing to be careful of, if you round off percentages, often they won't add up to 100%. So I kind of made these, I kind of fiddled with these percentages a little bit and make them add up to 100%, okay? So this is around what this is. And in general, what's it going to be? Well, it's going to be the number in that category, if we want to do it in general, right? The number in that category divided by the total number of people times 100%. That's how we're going to get the percentage in general. Right? So this is kind of like what we did when we were doing probability. Okay. And you notice these are the percentages, okay? So we can kind of get a feel for what's going on. We see that not a lot of people in first class and second class died, but a lot more people in the crew and in the third class. What we're really looking for here is kind of like the multiple, right? We see that these are about the same, and these are over twice this, okay? Between 2 to 3 times this. So a lot more people died, okay? And what are we going to do? The same thing we did for the bar chart. This is what we call a relative bar chart, okay? We're just going to plot the percentages exactly the same way. Notice they look the same, okay? But the information on the y-axis is different. Now it's telling us the percentage, okay, of the people that died, okay? So technically speaking, this is the percentage of people who died, okay? But exactly the same sort of plot. Okay. And if you want to give that a name, you can call that relative bar chart. We're just plotting the relative numbers for the percentages. Okay? So let's go ahead and do that with our data. Okay? And by the way, I should also mention you can plot a pie chart too, right? Where the area is proportional to the percentage. Yeah, Chloe.
So when we do this on the test, like, should we, if we get like 14.7%, should we round it to 15?
Yeah, it's easier to round it. I mean, unless you have a calibrated eyeball and you can see 14.7, I'd round it. But you have to be careful because, like I said, the percentages won't always add up. So I'll look at the numbers, but then you can go ahead and round it, okay? I mean, here, we're not trying to be really, to kind of answer your question also in a more general way, we're not trying to be like super specific. Okay? Whether it's 14 or 15 really isn't like that important for the purposes of the chart, okay? We want to kind of get a gist of what's going on. But on the exam, just don't be surprised if they don't add up to 100%, okay? All right. You can make a pie chart too. Which one do you make? It's up to you. Whichever one you think better communicates the information, okay? I like bar charts. You may like pie charts, okay? It's up to you. On the exam, though, I'll ask you to do one or the other. And most likely, I'll ask you for a bar chart. Pie charts are hard because there you really do have to estimate carefully, okay? For example, I do not know what 13% of a circle is by drawing it, okay? I can't estimate that carefully. But I can estimate this a lot more carefully. So I'm going to have you do this on an exam or a quiz. Okay. Any questions on this part so far? Pretty good? Okay. Let's go ahead and do the same thing with ours, okay? So let's go back and take our frequencies. And I just entered this, so I'm going to have to go back to this page. So here were our frequencies from class. And by the way, we're going to keep this the same. Notice that the plot itself doesn't change. It's just the axis that's going to change, right? So I'm going to keep that. And so let's go back and look at this. So we said that for action, we had 4. This is going to be the frequency. And we have what? Comedy, drama, horror, romance, and then other. So we had 4, 14, 4, 3, 5, 1. Okay. What's one thing I need to do to calculate that percentage? Find the total, exactly, right? Because I'm going to divide each of these by the total. So I'm going to add these guys up, so I'm going to get what? Make it 18, 22, 22 and 8's 30, 31. Okay, so I'm going to write this as total, so I know what this is. And now we'll just go ahead and we compute the percentages of each of them. Okay. So let's go ahead and do that real quick. I didn't have time because I just got the data from a few people before class, but we can do this. It's not hard. So 4 divided by 31. So I get about 12.9. I'm going to round that to 13%. And this guy's the same. I get him for free. Okay. And we just go ahead 3 over 31. It's about 9.67. I'm just going to round it to 10%. This is about 16%. And finally, this is about 45%. And just for the sake of simplicity, I'm going to make them add up to 100%. So I don't have to worry about rounding. So I'm just going to add these up and subtract these from 100, okay? So we got 13, 45, 23, 16. This is about 3%. Okay. All right. And so now we're going to go ahead and plot those. And notice the thing's going to stay the same, except now I'm going to change the units here, okay? So let's see, the largest one, I usually start with the largest one, it's 45%. And I'm going to make these in units of, say, 15 to start off with. 30%, 15%. Okay. And now this ends up being exactly the same. And you can do this from scratch, just to kind of test yourself, okay? So the shape is the same, we're just changing the scale. That's all. But exactly the same information. But what's more useful is that a person can read the percentage. If I were to know, okay, what percentage of the people like drama, I can go over and say, oh, okay, this is about, these are units of 3, this is around 12%. And the percentage of people that like drama is 13. Again, we're not trying to hit a bullseye exactly. We're just thinking kind of relative numbers here. So this is something I would expect you to be able to do on an exam. And in fact, the homework problem is going to use some of those other pieces of data we had from the class, okay? So any questions on that part? Okay. The last part I want to get through today, this is where it gets a little tricky. Okay, so, and we've already done this. Okay, so there's kind of a third way that we can organize data. Notice that knowing the percentage of people on the boat is not that interesting. We might want to look at another variable with the percentage of people who survived. Okay? So now we're going to look at two pieces of categorical data together. Okay? We want to see how the one piece is related to the other piece. All right? So if we go back to the Titanic, we're looking at class right now, passenger class, right? What's another piece of data that might be interesting? I mean, I have age, mortality, which is just, whether or not someone survived, right? And gender. What would be the more interesting thing to look at with class, do you think? What would interest you? What do you think, Sarah Jean? Mortality. That's right. I mean, none of these others, class and gender, I don't really care whether more women were in first class or whatever. But this I definitely care about. Okay, this is the main thing about the Titanic, right? So we're going to look at these two things together. Okay? And so here's the data. Again, if you go back and you summarize everything, here's the data. Let's look at the table kind of briefly, okay? So this is telling us the number of people that lived in each passenger class, right? the number of people that died, and this is the total. And by the way, I made an error earlier. When I did the percentage for first class, I put 285. That should have been 325. I was thinking of second class. My apology. Okay. You definitely won't get, well, whatever it was, 12 or 13%. Okay. And so what have I done? I've totaled the total number of people who lived, who died, and the total number of people in each class. Okay. It's always a good idea to kind of make a border where you total up things. Okay. Columns and rows. Now here's the hard part. It makes sense to plot a percentage now, okay? But the question is, what percentage do we want? Okay? And this kind of goes back to the drug testing, where we had to be careful what did we know? The information about the drug or the information about the person, right? This is kind of the same sort of thing here. We have to think about it. Do we want the number of people who lived that were in each class? I'm looking. If I do that, I'm only looking at this row, right? I'm looking at the percentage of people who lived that were in each class. Okay. Or am I more interested in the percentage of people in each class who lived? Which is the more interesting thing to look at? Okay. So let's take a look at both. And let's see how, if you make the wrong decision, you could come to wrong conclusions. Here's our data. So what I'm going to do is I'm going to look at the percentage of people who survived. This is the total group I'm looking at that are in each class. So here I'm looking at the percentage of people of those 711 that were in first class, second, third, and crew. Do you think that's an interesting piece of information? Well, let's see. Let's go ahead and do that. I'm going to take this 203 and divide it by 711. Okay? So I find out that of the people who lived, okay, 29% were in first class, 16% in second, 25% in third, and 30% in crew. Is that the thing that I'm after? What do you think, Lauren? Is that the thing that I'm after? Is that what I want? It is? So think about it. If it was, we always have to draw conclusions. What's the conclusion we draw from this table? First class and crew are about the same. Okay? You say, well, of the people that lived, the same percentage of first class and crew lived. So it really wasn't that important what class you were in. Okay? And by the way, you've never seen this. I've seen this data a million times. Okay? So I know the answer, right? We're trying to puzzle through it and think through it. Okay. Let's look at the raw numbers. Does the raw numbers suggest that? Well, not really, right? We see that of the crew, of first class, a lot of people lived from first class. But not a lot of people lived from the crew. Yeah, Evan.
One thing that I'm confused about, how come you took the first two out of the total number who lived, but the second two out of the total per, third and crew? Does that make sense?
You know what? Because I screwed up. These should all be 711. Thanks. And let me change that right now since I'm going to post that. Thanks. Sorry about that. The evils of cut and paste. I'll blame it on Microsoft. How's that? There we go. Thank you. Yep. That looks good. Okay. Okay. But let's look at the percentage of people in each class who survived. Okay. So here what I'm doing is I'm looking at the people in each class and I'm computing the percentage of survivors in each class. Okay? Now, notice those numbers tell a very different story, don't they? This is saying that, and what you really have to do is, if you write down the percentages, and I'm going to post this online, okay, you can go back and figure this out. But the key thing is 62% of first class lived and 25% of the crew lived. And that's what we're really after. We want to see if class affects survivorship. Okay, so we have to be careful what we compute. All right, we can come to very, very different conclusions. Okay, so we have to be careful here. What's actually going on? Okay, here's what's going on with the data. If we kind of go back to that Venn diagram, just to kind of illustrate what's happening. Venn diagrams are great, by the way. They're just not for Chapter 5. We can use them here, too. if you look at a Venn diagram, okay, these are all the people who lived. So we had 700 people who lived. And if we look at the class, okay, and these are all the 2,200 and however many people, right? This is all 2,200, whatever, one people. And this is first class and crew. They look like this. They almost have exactly the same number of people who survived. Okay? So they kind of look like this. But first class, this is 2/3 of all the number of first class, right? First class looks like this. This is the 203, and this is the 118. Whereas the crew looks like this, right? Okay? So what we computed the first time was we computed this. There's 212 for crew. We said, okay, the same number died in each class, so it didn't make any difference. But that wasn't what we were interested in. We wanted to see how class affected survivorship. We want the percentage in each class, okay? And we can see that a much larger, a much larger number of people, a percentage of people died in the crew. Okay, that's what we're actually looking at. All right. So you have to be careful. Usually it's kind of obvious, all right, but this is what's going on. Okay, we can go ahead and plot that. Again, you look at this table, and these numbers are really kind of hard to get a handle on. Notice I don't want to plot both things. I don't have to plot the percentage of people that lived and died, right? I'm only going to plot just the percentage of people who lived from each class. So if we do that, and you can compute that out, and I strongly encourage you to do that. Convince yourself that you can get these numbers, because this is exactly the sort of thing you have to do on a quiz or an exam. Okay, I can go ahead and I can make my bar chart. So here I'm looking at the relationship between survival and class. Here's my classes. And you notice that first class, it literally just goes down almost, right? With respect to, how high a class up person you were. Okay, a whole lot of people lived in first, and notice that less than half that percentage lived in crew. Okay, that's the way we want to kind of analyze the data. I'm not getting really technical, but we want to notice, especially when something's, a number of times larger than something else. That's what we want to catch. That's what catches our eye. Okay. Now, let me ask you a question. Some of you are in journalism and communications. Would it be okay to look at this and write a story saying, well, this is just another example of class warfare, right? The poor guy gets left holding the bag, and the rich people are okay. Is it okay to write that? Why not, Lexi?
Well, the numbers are not that skewed.
Really? I mean, 60% of these guys live, and around 20% of these guys live. I think that's a huge difference myself.
Well, you don't know the gender, so did you say male?
But I don't care about gender. All I care about is class. I want to make a claim that the richer people, they ended up ahead again, and the poor people, they got shafted. Okay? Can I say that? Yeah, maybe. It makes for a really good story, doesn't it? But here's the thing. We don't know. There's kind of an implication here, right? There's preferential treatment. So later on in section, I think it's 4, if I remember correctly, we're going to talk about these sorts of studies. Whenever we're using historical data, it's called an observational study. Observational studies cannot answer why something happened. They can only tell you what happened. Okay? All we know is that a higher percentage lived. We don't know why. It gives clues for historians. Historians did go back and look at this. Does anyone know the reason why? Any Titanic history buffs? I'm not, but I studied stuff. The reason why was the placement of the lifeboats. Okay, the lifeboats happened to be closer positioned to first class. The crew was probably doing stuff, okay, besides that. And so for those reasons, they think a higher percentage. Now, was it put there intentionally? We have no idea. Okay, it's just how the boat was built. Okay, but we can't say why. Notice, we can't even make a statement about rich and poor. We don't really know what these people's economic classes are. all we know is the class of ticket they held. And this was like a gala event. Some of these people could have got the tickets as a gift. Okay? We don't know what the people in the second class were like as far as their income. So see, we can't say anything that's not in the data. We can only say exactly what the data tells us. We can't read into it and make our own interpretation. Yeah?
But you said that you wouldn't necessarily be interested in gender, but there is proof that there are actually more first-class men than
Yeah.
third-class women and children, and third-class women and children should have been off the boat first.
Exactly. And you're right. There are interesting questions. This isn't the one we're addressing, but you're right. If you look, and in fact, one of the homework problems is looking at mortality and gender. And it turns out a lot more women and children survived, although it's not a gender, it's age also. A lot of them survived over men. And because this was the second time in maritime history they used the phrase women and children first. Okay? So you're right, there are other things we could look at. But if we're just looking at the class of the passenger ticket and mortality, we're just limiting ourselves to that question, okay? And there's some fascinating stuff, by the way. It turns out, I'll tell you this real quick so we have a little time. When they looked at the bodies, some of the bodies of the guys had bullet holes in them. And they were trying to figure out why. Like some of these guys were rich. The Astors were on there, for example. Did they have a gun and shoot themselves? They knew they were going to die. It turned out the reason why a lot of the men died was the captain gave orders to two people. And one person interpreted the orders as women and children first. Okay? Another person interpreted it as women and children only. And so there were actually empty lifeboats that went down because this guy would not put men on there and shot men who tried to get on. I know it's crazy, but this is what happened historically, okay? So you're right, there's some fascinating stuff with gender here too. And we're going to do that for a homework problem. Okay. And now, why do I say this? Okay, so for you guys in communication, at some point you're going to have to deal with some statistics in some shape, way, or form. You make presentations and stuff like that. You have to realize statistics deal with things that are sensitive. Deal with things like age, gender, race, religion, ethnicity, education, socioeconomic background. We have to be careful what we say. Okay? When you look at the news, I see this on a weekly basis. People will say one thing, like they'll say something like, oh, class warfare, just another example, because they're looking for that. And when you actually read the story, you say, is that really what happened? If you start reading the news carefully, you'll see that happens a lot more times than you might like. Okay, any questions on any of this? All right, let's sally forth. So, and again, you can plot a pie chart. I'm not going to ask you to do a pie chart, okay? But you're going to see that a lot. People like that in presentations, okay? And sometimes it's actually better than a bar chart, but I'm not going to have you do that. So let's go ahead and do this now. With our case, let's look at gender and let's look at movie genre. And again, what percentage are we going to look at, okay? We're going to want to look at the percentage of each gender that liked a certain movie, okay? So, again, I didn't have time to do this because I collected the data, but let's just go ahead and kind of puzzle through it. Okay, so for the females, we have 19 total, right? So for the action, it's going to be 4/19. So we'll make what we call a contingency table, okay? So for the females, it's going to be 4/19, right? We're looking at the percentage of females that liked action. I'm going to multiply that by 100%. For comedy, it's going to be 8/19. And this number will just be twice this. I only have to compute it once, right? For drama, it's going to be 4, 2, and 5/19. Notice if we compute 4/19, we can just double it and half it. So we only have to compute two numbers, okay? That's kind of nice. Okay, so 4/19, let's do that real quick. So we're going to get about 21% for the females here. I'm just going to double that. Okay, and then half that. So we'll say 11%. And I'll half that again. I'm going to make that about 6%. And then we're going to make these add to 100%. So I'm just doing this kind of quick, but you might be a little serious. And this is going to be about 20%. Okay. So even though those numbers are rounded, they're pretty accurate. Okay. All right. Let's go ahead and do the guys. Let's see if gender affects movie preference. So here for the guys we have 8. So this is easy, right? We have 0 for action. A lot of guys like comedy. 6 over 8. That's just 75%, right? And we have 1 for horror. So this is going to have to be 12.5%. And we have 1 for romance, 12.5%. I'm sorry, other. I'm sorry. Nobody for romance. And 12.5% for others. Okay? And so now what we can do, here's kind of a nice way we can summarize this data. And so you look at this, and one thing you have to be careful of is you have to be careful of generalizing, okay? So you notice that a very large, a significant portion of the women liked romance. Every other class I've done this, that hasn't been true, okay? So, we're seeing something that kind of comports what we think we should see, but it's not always true, okay? So let's go ahead and plot these, and here's how I'm going to do this. I'm going to make, if you want to give it a name, I'm going to make what we call side-by-side relative bar chart. I'm going to put the percentage who like the genre here, their favorite genre. And here I'm going to put action, and I'm just going to put a label: A for action, C for comma, D for drama, comedy. Sorry, I'm combining the two: comedy, drama, horror, romance, and then other. Can everybody see that? Is that visible? Okay. So what I'm going to do is I'm going to plot the percentages side by side. Okay. I'm going to make the females be a dark color and the guys be a light color. So I notice the highest one, my eye always goes to the highest one, 42%. So I'm going to make my 40% up here, and then just put a line here for 20, and then 10. Okay? So 21% of the women like action. Zero percent of the guys do. 42% of the women like comedy, so they're way up here. And 75%, so I made a mistake, I need 75%, right? Let me erase this, sorry. I didn't see a 75%, I was looking at the females. I gotta extend my graph here, right? This is going in 20, 20, 40, 60, 80. So 75% of the guys like comedy. The guys are going to be not shaded. Okay, for drama, 11% for the women. 0% for the guys. Horror, 69%. I'm sorry, 6% for the women. So that's down here. And the guys were 12.5%. Romance was 20% for the women. 0 for the guys. And finally, 12.5% of the guys liked others. Okay. So here, you have to put a little legend telling people which is which. This is the females, and this is the males. And I'm able to compare those side by side. Yes.
Maybe I got confused, but I got a little lost.
Sure.
You had action as 21% and drama as 11%.
Okay.
But they're both 4 out of 19.
Let me check real quick. Action. You're right. I apologize. You're right. This should be also 11%. Yeah. And I'll post this online. I just really want to show you what to do and how. But I'll post a good version of this. Okay. Yeah. So sorry for that confusion. You're absolutely right. Yeah. Okay. So this lets us compare the two side by side. This is kind of like a variation of what we did, okay? But this is a good way to do this, okay? And on the exam, you want to try to be accurate. I'm doing this at the board, okay? But I'm trying to use like equal spaces. Try to be accurate. You can use a ruler and go over. All right. Okay. So this is that side-by-side bar chart, okay? Or side-by-side relative bar chart. Okay, so let's just kind of recap here, okay? This is what's important, what you have to know for sure. So for one piece of categorical data, what can we do? Well, we can plot the frequencies and we can plot the percentages. We make a table for both, right? And then we go ahead and plot these. So we can make a bar or a pie chart, or we can make a relative bar or a pie chart also for percentages. Okay? If we have two pieces of categorical data, what do? We make a table again. Notice we always make a table for categorical, okay? No matter how many pieces. And then we can make a bar chart of the percentages. All right? One thing I want to mention real quick is that notice we didn't compute any means, any standard deviations, no ranges or nothing, because it doesn't make any sense, right? So you have to be careful and realize that there are very few numerical quantities that we can actually compute. Remember we said before that we were going to do this summary statistics at the end? After we got the plot, we were going to give some numbers. There's only one number we can give that actually makes sense. Does anyone know what it is? We haven't talked about this yet. What's the only thing I can talk about? And it isn't even a number, actually. I can talk about the mode, okay? I'm not going to ask you for that per se, but the mode's just the category that has the most. We're going to talk about that more when we do quantitative, okay? But we can't compute means or standard deviations. The only thing we can get is the mode. Okay, here's some homework problems I'm going to give you. So this is data on the Titanic, and this is going to go to Lexi's problem. So we're going to start looking at gender here first. So I'm going to ask you to make a bar chart of the frequencies, a relative bar chart of the percentages, a pie chart for the percentages, and I want you to make some conclusions. It's kind of like what we did, okay? A certain class is so many times more than this, okay? And then you're going to start looking at survivorship, okay? And you're going to make conclusions. And then I'm going to have you do the cell phone data, the same thing for the cell phone, okay? And that should do it for the homework. All right, I'm going to hand back quiz 3 real quick. And I think that'll do it for today. By the way, the extra points that I added to the quiz, I've already done it for everyone, so if you didn't receive it, let me know. I did it in such a way that it'll be the maximum benefit, okay? I added them to your existing quiz grade. I owe a few people points because they have perfect papers, but I kept record. Okay, we'll pick up, and then next class we will stay in the book, I promise, okay? We'll go back to the book.